Okay, so let us let's continue. They said a uniform rod with weight 30 newton. Don't forget that the weight is always at the center. Okay, so a uniform rod with weight 30 newton. In fact, they have drawn everything for you. So they now say we should find the forces or the weight at this support on this knife edge. Okay, now to find the weight of x, let me call it wx, or let's say that x is the weight. Now if you want to find this one, okay, you are going to close that there is no knife edge here, so that everybody will react on this person, on this knife edge. So if I'm closing this, all the forces are reacting here, which means there is no force here. So I'm closing this now, so this man is reacting here, this one is reacting here, this one is reacting here, and finally this one is reacting here. Okay, so what do we have? Which one is clockwise? This one is clockwise. So x times, from here to this place is 3 plus this, which is 8. X times 8 plus the next clockwise is this one, 10. So 10 times what? 5. Okay, is equal to, now all the anti-clockwise, 30 first. 30 times 5 plus the next one, 25. 25 times, let's calculate it, from here to this knife edge is 4 plus this is 7. 7 plus 5 is 12. Okay, so 25 times 12. Okay, so what do we have now? We are going to have, this is 8x plus 50 is equal to 150 plus 25 times 25 times 12 is 300. Okay, so I'm having 300. So what do we have now? Other items here is 450. So 8x is equal to what? 450 minus 50. So what? 8x is equal to 400. So x is equal to what? 400 divided by 8. I'm having 50 newton. 50 newton. So that is for x. You can do the same thing for y. If you want to do this, if you want to get y, just close here so that everything will react on this. But no need of doing that, because we know a law that says that upward force is equal to downward force. So the upward force there is x plus y are the upward force. So upward force equals downward force, or forces. Sum of upward forces is what? These two, x and y, is equal to the downward is what? 25 plus 30 plus 10. So what do we have? X is 50 plus y is equal to this is a 40, 55. So y is equal to 55 minus 50. So y is equal to what? 5 newton. As simple as that. So is it 55 or 65? 65. So I'm having 15. Okay, so that is that. You see, very simple. So let's solve another question. So the next question said, they gave us something like this, and they said that here is 30, and this is a knife edge here, this is 80, and I'm having a weight here, this is 3 kg. Okay, and I'm having that here is 10, here is m, here is n. Okay, and I'm having that here is 20. Okay, which other thing? All right, so, and I'm having that here is tension T, and here is P. Okay, here is R according to them, here is L. Okay, then I said in the figure, above, comma, mn is a light uniform meter. Light uniform meter rule pivoted at 0. Pivoted at 0. comma, okay, pivoted at O, not 0, pivoted at O, the ATCM mark. So here is O, not 0, but O, okay, ATCM mark. Then I said a load of mass 3 kg is suspended on the rule at L, comma, the 10 cm mark. Okay, if the rule is kept at equilibrium, kept at equilibrium by a string SP, string RP, a string RP, comma, fixed at P, okay, and attached to the rule at R, comma, the 20 cm mark. The 20 cm mark. Then calculate the tension on the string. Calculate the tension. Calculate the tension T on the string. Okay? We have to calculate the tension T on this string. Okay. The first thing we are going to do is first of all, this mass will be converted to weight. Okay, we need to convert it to weight. If we convert it to weight, we have that it's already in kilograms, so it will now be 30 newton because weight is equal to what? Weight is equal to mg, and mu is what? 3 times g is 10, which is what? 30 newton. We have converted it. So now we need to resolve this thing to stand up, and if you are resolving it, we are resolving it away from the what? Away from the angle. So, and the way all Saints Teresa's College, away is sine. So here, if this thing is going to stand up, it's going to be T sine what? Sine 30. Okay, it's going to be T sine 30 because it is away from the angle if it's going to stand up. So, and I have is there any other thing we need to do? There's nothing else we need to do. We need to just know that upward force is equal to downward force, or we take the moment. We can decide to take the moment. If we take the moment, we're having that let's take the moment because we're having equilibrium here. Okay, so let's take the moment. This is clockwise and this one is anti-clockwise when it's going to stand up. Okay, if this is standing up, it's going to be anti-clockwise moment. Okay, from here to here is 80 and here is 10, here is 20, so this is 30 minus this, so all this place is 50. Okay, so it's going to be this tension T sine 30 times your 50. 50 from this R to this point is 50. I hope you know, like this is equal to this one now, which is 30 times from here to here is what? This is from here to here is 20 plus 50. What? That is 70. Okay, so 30 times 70. So what do we have now? This is half. This is half. This is 0.5 T times 50 is equal to what? 2100. So what do we have? Half of this is 25. So I have 25 T is equal to 2100. So T is now 2100 divided by 25. So T is equal to 2100 divided by, how did I get 25 instead of 30? How did I get 50? Is it 50 or 60? Let us check. From here to here is 10. Okay, from here to here is 60. Sorry, is 20. Sorry, from here to here is 20, please. So here is another 10. So it should be 60. Sorry, this minus this is 60. So it's 60. 60. So this is 30. So this is 30. So I'm having 70 Newton. So as simple as that. As simple as that. So okay. So let's take another question. Let's take another question. See, it's very simple. So that all cent will help you. All cent, the Isaac College will help you. Okay. The next question says a uniform meter rule 0 is balanced at this as shown above. Okay, so they gave us this. They gave us this. I think this is the last one I'm going to solve. Or do I solve more? Let me check. Okay, let me solve this. They gave us this, and they gave us that from here. So let me use one single line instead of drawing the meter rule. Let me just use one single line. I have this. They gave us that here is Q, here is R. Okay, and they gave us that from here to a point P. A point P is there is a force here, 10 kilogram. Okay, or 10 gram. They have 10 gram here, and that here is 10 cm. Okay, they now said a uniform meter rule, QR, okay, is balanced on a knife edge, which is 55 cm from R. When a mass of 10 gram, when a mass is hung at P as shown above, calculate the mass of the meter rule. Calculate the mass of the meter rule. Okay, as simple as that. So if you want to calculate the mass of this meter rule, don't forget that the mass of any meter rule is always at the middle. So if I have this now, I'm having this from 0 to 100, and the mass is at the center. Let me say that this is center 50, and the mass is what? M. Okay, this is the mass, and they hung something here at 10 gram at 10 cm, and it's being pivoted somewhere here. They pivoted it at what? Knife edge as 55. Okay, so the knife edge is at here 55. This is the knife edge. This is, so here is 5. So here is 55. Okay, so what do we do now? Okay, 55 from this side. Sorry. Let us do this again. I'm having this from 0 to 100. Sorry for the interruption. I have that is pivoted 55 from this side. So 55 from this side means 45 from this side. I hope you know. So and this one is already at the center. This is the mass at the center. Okay. So and the mass is at 50. So this one is pivoted at 45. So here should be 5, because from here will not be 55. From here will not be 45 to make it complete 100. So and I have a mass hung at 10. This is 10 gram hung at 10. So 45 minus 10, I'm having that here is 35. As simple as that. So this go this way, this go this way. So I'm having what? 10 times 35 is equal to what? M times 5. So M is now what? 350 divided by 5. So M is equal to what? 70 gram. As simple as that. So the next question. Okay, they give us something like this and this one like this. Okay, and here is 30. And they say that from here, this is O, and from here to here is 20 cm. Okay, and they gave us that there is a force here, F, and that force from here to here is 30. Okay, and they say that here is Z, and here is X. Okay, here is tension T. Which other thing? Nothing again. They say a uniform light beam XZ is hinged at O. Okay, is hinged at O. That is where the knife edge is. It's hinged at O. Okay, and kept in equilibrium. Kept in equilibrium by the force T, and F as shown above. If X is equal to 20 cm, comma, OY is equal to 30 cm, comma, then I say express T in terms of F. Express T in terms of F. The first thing we are going to do is to resolve this man to stand up. So, and if he's standing up, don't forget it's going to be what? This is 0. If he's standing up, it's going to be what? T sine 30. Why is it T sine 30? Because of this ASTC. So away is sine. So he's now standing up. So don't forget that I have a force here, and that force is F at 30, and here is at 20 cm. So how do we resolve? Everything we are resolving is at O. Okay, is at where are we resolving it? Okay, so since there is no pivot, so we are resolving at an end. So I'm moving this way and I'm moving this way. Okay, so what do we have now? This one is 20. So what am I having now? 20 times this, is it not? This times 20, so I'm having T sine 30 times 20 is equal to what? F times this plus this is what? 50. So what do we have? I'm having that what? Half of this is this is 0.5 T times 20 is equal to what? 50 F. So what am I having? This and this is 10 F is equal to what? 50 F. 0 cancels 0. So F is equal to what? 5T. T is equal to 5F, sorry. And that is that. So now let us now start solving question on non-coplanar. We have been solving on coplanar all this while. So let's now look at question on non-coplanar. I hope by now you can be able to draw any equilibrium. Draw it by yourself and then solve it. Okay, so now let's start by non-coplanar. They say that a body of weight 10 Newton, okay, hangs from the free end of a piece of wire whose other end is fixed to a rigid support. Then a horizontal string attached to the body exerts a force which is kept which keeps the wire at an angle of 30 degrees to the vertical. Find the tension T1 and T2 in the wire. T1 and T2 in the wire and the string respectively. Okay? Alright. So let us read this so that we know what to do. They say that a body of weight 10 Newton, the weight of that body is 10 Newton, okay, is hung from the free end of a piece of wire. Free end from a piece of a wire whose is fixed to a rigid support. I have a support like this. Then I now fix a wire like this. Okay. Then there is a weight that is fixed on this. That weight is 10 Newton, and the weight of something adds down weight. Okay. Then a horizontal string is attached to the body. A horizontal string is attached to this body. Okay. A horizontal string is attached to the body. Exerts a force which keeps, there is a force that this horizontal body exerts, which keeps the wire at angle of what? 30 degrees with the vertical. So there is a vertical here and it makes an angle of 30 degrees. This is the wire making an angle of 30 degrees with that horizontal. Are you getting it? As simple as that. This is very simple. Okay, so making an angle of this with that wire. So what do we do now? Let's start resolving it. Now if you want to resolve this thing now, if you look at it, it has already formed a triangle. This line is this line. This line is the one that will cover here. So I'm having a triangle like this. I'm going to solve it two ways. So I'm having a triangle like this. Here is what? 30. And this one standing. The weight is acting downwards. So this is 10. So I'm looking for F1. Let me call this one F2. The force on the wire, F2. So they say F1 and F2. Okay, F1 is for the wire, while F2 is for the string. Okay. So as simple as that. So to get F1, this is adjacent over hypotenuse. So cos 30 is equal to adjacent 10 over hypotenuse F1. So F1 is equal to what? 10 over cos 30. So which is what? 10 over root 3 over 2, which is equal to what? 20 over root 3, which is what? 20 root 3 over 3. So that is that. So for F2, opposite over adjacent, so tan. I'm using tan, so opposite over adjacent, so tan 30 is equal to opposite F2 over adjacent 10. So what am I having? F2 is equal to 10 tan 30. So which is what? Which is equal to what? 10 root 3 over 3. Because tan 30 is root 3 over 3. So as simple as that. But I'm going to solve it in another way. Okay, in our next class we'll continue.